of Boolean algebra. He wrote the paper of mathematical analysis of logic, which represented logical forms, and it's the form of logic used with 0 and 1. He expanded Leibniz's earlier speculations and did work in differential equations and probability, and he first discovered distributive property. This is how he did it. He stated that he could use symbols to represent selections of things.
You need to talk louder.
Okay. If x is horned things and y is sheep, then 1 minus x would be all things not horned, and 1 minus y would be all things not sheep. So therefore, 1 minus x times 1 minus y equals all things not horned and not sheep. This is how he discovered the distributive property. So what is Boolean algebra? So if I told you you had a lie and a lie, what would you think that would be? A lie. So if I had one lie and one truth, that would still be a lie. And then you can see you would fill in right here. So it'd be a F, false, F, false, F. And then two truths would be a true. So in the next slide you can see if there is a false, it's going to be false. The only way it's going to be true if they're all true. So let me go to the next one. Is or. So if we have two truth value of one truth or one lie, that one's going to be true because it's an or statement. And the truth of two lies is still true. So to make it more easier to understand, if it's got one t in it or one true, it is true. The only reason it's false is if they're both false. So to explain the and or statements, so if I said to pick a card that's 2 and red, you'd only have 2 cards. So then you have the or statement. If I said 2 or red, you'd have all the 2s and all the reds, which makes it a bigger selection. So the difference, as you see in the ones and zeros, 0 represents false and 1 represents true, which is the table represented. So 0 and 0 is 0, 1 and 1 is 1, 1 and 0 is 0, and then 0 and 1 is 0. And then, as you can see, 0 here, the ones are, if it's included with a 1, it is 1 on the or statements, and then the simple one is not. If I say not 1, 0. Not
Explain why is 1 and 1 just 1?
1 and 1. So if I have something and something, it's still something. Okay, so like I said, it's used in terms of 1 and 0, which is true and false. So it's just the same table, just expressed with 1 and 0. So how does 2 to the x come into play in Boolean algebra? So if I have the a, b, and c variables, that's 3 variables. So 2 to the 3, 8. So you can see over here, we're going to have 8 different ways you can make 1 and 0. So the first one's going to be 0, 0, 0. The last one will be 1, 1, 1. And then you just play with them to make each one in there. So then if I have A, B, C, and D, it's 4 variables. So let's do the 4th. So then there's 16 different ways. And then Boolean algebra is used today, which is surprising because he came up with this in the 1800s and we didn't have computers back then, and they use it now. They use it with capacitors, with like 1 being on and then 0 being off. It's used in electrical engineering, satellite pictures, and telephone circuits. And in summary, George Boole, he used mathematical concepts to express logic in philosophy. And he discovered the distributive property and used the truth tables to express the values. And then Boolean algebra is used today. Those are my references.